Hello, I am Manojul Singh Aneja, pursuing my Masters at Information Security at Thapar University. My research topic is Artificial Intelligence based Intrusion Detection System to detect flooding attack in VANETs. So, what is a VANET? VANET is a vehicular ad hoc network. It is a network of moving vehicles. Basically, the Google has come up with the driverless car, so this VANET supports the driverless car. That is, by virtue of VANETs, a car can communicate with the another car, or for the media transfer, or for some emergency messages like changing of lane or reducing the speed of the vehicle because of some diversion ahead. So these are the type of communication that can happen over a VANET. It is dynamic, it doesn't have any infrastructure, and because of mobile nodes, it has frequent disconnections among the networks. So there have been a lot of applications like safety applications to let the vehicle know that there is a diversion ahead, so slow down, or there could be a commercial application, or there could be a convenience application, for example for some transfer of some media files, etc. By seeing all these challenging issues, the most high priority challenging issue comes in terms of security. They are vulnerable to many security threats like denial of service, wormhole, Sybil attack. So in my research topic, I have particularly focused on detection of root request flooding attack. Now what happens in root request flooding attack is that in root request flooding attack, a particular node, an intruder node, tries to send a message or root request packets to a node which does not even exist in the system. So by virtue of which the channel gets occupied and the legitimate nodes are not able to send the packets because the channel is busy, or the number of root request packets sent in the whole network reduces because of unavailability of the channel for some particular time when the intruder node is trying to send the root request packets to the destination which does not exist in the network. So this is my problem statement, that vehicular networks, because they are vulnerable to many security threats which could even risk a life of a person, we need to have a secure routing protocol. The routing protocols do not have security imparted by default. So in the research work, detection of root request spreading attack is done using artificial intelligence. So the objective is to launch the root request spreading attack and calculate the packet delivery ratio and throughput print, so that we study what effect of these two parameters have on the network under the influence of an attack. To create an own dataset having substantial amount of normal and attack records, to reduce the number of features using genetic algorithm. This is the optimization strategy that has been applied to reduce the number of features, and to calculate and compare the performance matrices with the other research works. So these are the tools that we have used: Sumo, Move, NS2 and MATLAB. MATLAB has been used for the artificial neural network and genetic algorithm, and NS2 has been launched for launching an attack, because we want to create our own data set, so we need to have attack records as well. So for launching an attack we have used NS2. Move and Sumo have been used to create a VANET environment. They generate a TCL file which is used by the NS2, where we make changes in the files of AODB routing protocol. So the proposed architecture is composed of three stages, where the first one is the creation of the data set, where we create a data set. Second one is the pre-processing, and the third one is the classification of the optimization engine. So for preparation of data set, we need to create a VANET environment, which is done using Move simulator. So this is the Move simulator. Here we pass all the files like node, edges. I've already created all the files, so I can show this one. So like this, we'll give the coordinates of all in the node file, like edge, all this will do. After doing this, we'll generate a TCL file. This TCL file is something like this. Then we run it on the simulator, NS2 simulator, like this. It is going to take some time. So after generating, this is the NS2 simulator where we launch an attack. We run like this. These are the VANETs that are moving. After creation, after this, we'll get a trace file. So we'll just close this. We will get a trace file. The trace file is generally like this. It's a big file. It takes time to load. So this is a trace file that we get. After getting the trace file, we create a data set. We normalize the data set because some values would be hexadecimal, some would be integer, some would be alphabet. So we normalize them. It comes like this. This is basically proposed architecture. We have discussed the creation of data set and data preprocessing. So after creation of data set, now we come to artificial neural network and generic algorithm, which is basically a detection and optimization engine. Here we have created 10 subsets of dataset and run that 10 number of times for each subset of dataset, so that our dataset is not partial, our results are not partial. We take the mean of all the 10 values that we get. So for the artificial neural network, we simply pass, that's the code we have written. So there are 22 number of neurons in the input layer. There is one hidden layer consisting of 10 neurons, one output neuron, which gives us the value as either 0 as 1, that is attack or not. We have run this artificial neural network for misuse detection as well as for anomaly detection. The misuse detection is when your training and testing is of same data set. Anomaly detection, or basically new attack detection, is when your testing and training data set is from different data set. So it is running here. Just pause it. So we get this as 98.3% as the accuracy for this subset of a data set, that is the first subset of the data set. Similarly, we run it for all others and then we get the average as an accuracy. This was the part of artificial neural network. Now this is the part for optimization engine. We get the values here as the total values and the least fit will be removed from each iteration. So these are the results. That is, when we increase the number of malicious nodes, the PDR decreases. Similarly, the throughput decreases. This is to study the trend of the PDR and throughput under the influence of an root request flooding attack. This is the result of our accuracy, and compared with others, we have these results. Future, we would like to detect more attacks, reduce the number of features to below 18. In this, we have been able to reduce the features to 18.